The second manner that data storage can be laid out is according to the data-driven organization value map, which any organization can customize according to its own internal and external contextual factors. This approach requires that we start with the value map layer as the main overall data pod. So similar to the function-driven layout, just like each function would have its own main overall data pod in that approach, for this approach, each value map layer would have its own main overall data pod. Then, each value map level will contain sub-data pods, housing all the data related to each of the data-driven categories or objectives of that specific value map level. So for example, at the product value map level, if the given business or organization operates within the consumer products and services space, it would have specific products and services that are at the core of their offering in that space, sometimes one product type offering, often multiple types of product offers such as food, cosmetics, beverages, clothing, and so forth. Similarly, for financial services, for example, the company in question might be dealing in a number of specific financial services offerings, such as equities, sales and trading, wealth management, private banking, investments, and so forth. Say, for example, that a specific business is an investment bank that only deals in equities, sales, and trading, as well as wealth management. Then each of these specific product or service offerings will have its own sub-data pod within the product view value map level. This can even distill even further, creating subpods within the product or service subpod, because within equities, sales and trading, sales can relate to stocks, foreign exchange, or other financial instruments. Each of these sub-service or products are substantial financial services offerings in their own right, requiring quite complex data-related management and usage models that would necessitate the existence of data serving that particular offering or sub-product or service and containing structured data related to that specific offering. Going down a level, to the strategic view level, a similar approach applies. Each value map objective on the strategic view level will have its own data pod within the main pod of that specific value map level. There will be data related to the objective of multiple customer segmentation within each of the product view level offerings. This is where one can start worrying about data duplication, which is why it might be wiser to have data reference instances that identify and carry specific data across the data ecosystem, instead of storing actual copies of data in each data pod. Either that, or ensure, regardless of the frequency of data update, that there's very little data update delays from the main big data storage to the data pods and to the sub-data pods and so on. The risk of using outdated data increases with each second that passes waiting to update data from one pod distillation to another. Right then, now that we've unpacked the activity of defining of data storage design in greater detail, let's now continue with the distillation of our organizational design exercise as related to the component of data. So the next step is the design of the data model across the overall data ecosystem, as well as the design of all the functions related to the design of the data ecosystem itself. Now, while data update is mainly an activity related to data storage, it also features quite strongly when considering the exercise of data transfer from one point to another. The next step involves working out what it will take to migrate the data ecosystem from its current form, if one exists, to a future form, or to build a data ecosystem from scratch, using the data setup or layout that currently exists within the organization, in terms of infrastructure, hardware, software, and so forth. Once these requirements are laid out, then a migration solution can be developed, in terms of the best and least disruptive way to move from the current to the future state data ecosystem. These can be developed concurrently to the activity of developing data management and usage policies and procedures, while also planning out the migration timing, spacing, and risk mitigation strategies for each stage of the migration. And that's it for data as an organizational design component. We now move on to the component of systems, the subcomponents of which include system architecture design, which involves the creation of a blueprint by defining structural elements, components, interactions, as well as operating environment. System architecture and integration optimization involves optimizing the workflow of integrated systems in order to improve efficiency, reliability, and performance. The last subcomponent, system migration, which involves moving data, applications, and workflows to a new system environment, as well as system asset management, which deals with the management and tracking a business's software and other technology assets, with the objective of ensuring that they are used efficiently and effectively. The distilled process is very much similar to the one of the component of data, which starts with collecting information to figure out the current setup, designing the future state architecture, optimizing the said architecture, and defining policies and procedures. The process concludes with designing the migration solution and implementation plans for moving from the current system environment to a future state system environment. The information needed to understand the current state of things includes systems that exist in the current landscape, the integration and workflows in the current system landscape, the number and list of functions performed across the current system landscape, assessed against the list of functions currently performed by data models in the landscape, as well as comparing these two function lists to the list of functions to be performed by the future data ecosystem in order to avoid duplication. From this point, the future state system architecture can then be designed, ensuring that there's no duplication of functions between the future state system architecture and the future state data ecosystem. The beauty of a well-designed and functioning data-driven environment internally within an individual business is that risky and time-consuming system integration is often not necessary in this context, because this integration is most often necessitated by the sharing and exchange of data, which can autonomously, effectively, and accurately be done outside of both systems without integrating them. Systems are often a very expensive part of a business's infrastructure, so knowing how much value is to be extracted from them, for how long, and the various scenarios related to the return on investment of the given system is extremely important, both from the infrastructure management and cost management prudence perspectives. Creating and maintaining an asset register that includes all of the business's technology assets, from hardware and software to digital assets, is a good start. Policies and procedures are key to any well-run and managed technology environment, in terms of usage, maintenance, the management of licenses, and so forth. The process concludes with the design of the migration solution, followed by the planning of the implementation of the migration. Right then, let's do a quick recap. Since the organizational design processes of data and system components are so closely related, it makes sense to synchronize activities to ensure sharing of resources, as well as the avoidance of duplication of work, especially considering that both processes start with the collection and alignment of the same information. So these activities can be aligned and synchronized to make sure that the design processes are working off of the same key information, aligning the inputs, and ensuring that all key considerations between both components are covered. The outcome is data and system organizational design future state outputs with a strong data-driven repertoire, where the system's landscape is stable and highly productive, where effective and efficient use of data leads to optimized and cost-effective operations, impactful and results-driven innovation, as well as informed and competitively superior decision-making. And that's it for Chapter 2.2. Join us in Chapter 3, where we'll unpack the case study with which we'll demonstrate the use of the DIY organizational design framework we've just spent the 2 parts of Chapter 2 developing.